Okay, on to our next question. In this one, they're giving us a function. I'm just going to read the question. It says a curve has the equation, whatever, that very long thing. And they said they're telling us k is a positive constant. And they say find in terms of k the values of x in which the curve has stationary points and determine the nature of each stationary point. So whenever I hear stationary point, the first thing I'm thinking is derivative. And I know the derivative function, well, dy, not x, dy over dx is going to have to be 0. So first of all, I'm going to rewrite that just so that it's a bit easier to derive. So 1 plus 2x plus k squared, 2x negative 3 all to the power of negative 1. And now I'll derive. Let's do, haven't done red in a while, so dy over dx. The 1 is going to disappear, that's just a constant. We have the 2, and I'm going to bring the negative 1. Well, I don't have to write the 1, but anyway, I just did now. And outside first, and then 2x minus 3, leaving the inside, just to decreasing that by 1. And then the inside is 2x minus 3, just becomes 2. And basically this whole thing has to be, I'm just going to rewrite it. I'm just going to bring the 2 to the front there, because I did write something there. Okay, cool. So this whole thing is going to have to be equal to 0 if I want to find the stationary points. So let's carry on, and I'm gonna, let's write it in a nice form, like 2k squared at the top, and then 2x minus 3 squared. This should be equal to 0. Gonna, well, add this thing on both sides, very big, long, tedious little fraction. 2x minus 3 all squared. I'm going to put this over 1 just to show that I'm going to cross multiply. So these two things multiplied is 2, I'm just getting rid of the fraction, is equal to, well, it's just 2k squared. And how lucky am I that these 2's are, I love it when a plan falls together. It's just kind of disappear. Going to divide by 2 on both sides, so I'm going to be left with this. And then I'm going to take the square root on both sides, and k is going to be plus or minus 2x minus 3. Now I have two options, which makes sense because they said stationary points. So on the one side I can have k is equal to the plus is the 2x minus 3. We'll quickly finish this one up. Oh, well let's just write the other option. We have k is equal to negative 2x, and then negative times negative is plus 3. So those are the two options, but I have to write x in terms of k. So I'm going to, let's say k plus 3 is 2x, just adding 3's on both sides or taking it over and dividing by 2 on both sides. So this, I'm left here with x is k plus 3 over 2. That's one answer. I think I'll probably just write it here as one of the answers because I'm going to have to do some working out here. So one option is k plus 3 all divided by 2. That's option A. And then this one I have to rearrange. If the 2x comes this side, it's going to be positive. This 3 stays here. And then the k comes over. It's a negative k. And then x 3 minus k all divided by 2. That looks correct. And I'm just going to write it here. So 3 minus k over 2. Okay, so now I have my two x values. So at this point is a stationary point, and x value that is a stationary point. I don't know what k is. I don't think we actually will find out what k is, but that's not important. They just want the the nature of these points. So the nature of the points they want to know whether these we can do one of two things when they ask the nature. We can do a table of values and just find out a number before and a number after, whether something will be positive or negative. Here it's going to be a little bit tricky to do that because we don't have that actual number. So the easiest is just finding the second derivative, and then seeing what the sign is of that second derivative when we input the x value. So let's take a look. I'm going to take all this away. Just going to leave my derivative there. because I'm going to have to derive again. So dx squared, this will just kind of disappear. And now I'm going to have to do, where is my, yeah, so just basically the chain rule. Negative 2 times 2 is going to be 4k squared, and this is going to be 2x minus 3 to the third power. And I'm just going to rewrite this nicely, 4k squared and all 2x minus 3 to the power of 3. Okay. Whew, now we have to fill in this into this. Fractions in fractions. How lovely. Let's see what happens. Okay, so I think I'll do, let's just sub this one in first. So for stationary point 1, for stationary point 1, let's just sub that in. So it's going to be 4k squared all over, let's do this, 2x is k. Oh, that's convenient. These 2's are going to cancel. Okay, now I'm feeling a little better. Anyway, so these 2's are going to cancel. And oh, look at that. We're going to have a plus 3 and a minus 3. So we're going to be left with 4k squared over, inside there it's just going to be k to the power of 3. And I can reduce that to 4 over k. Wow, that's nice. I kind of expected it to go a lot worse than that. Yeah, anyway, so they told us that k is a positive constant, so this is positive and 4 is positive, so this is positive. We don't really care what the number is, but because it's positive, I know it is a smiling function, and it will have a minimum point. So this one will have a minimum point at that x value. And the next one for the stationary point, let's, well, I'm just going to take this away. Hopefully this one works out so nicely as well, but I mean, it should. And I'm just going to cheat a bit and just use that top bit again, and then 2 times my x this time is 3 minus k over 2 minus 3 all to the power of 3. And then these would cancel out, and I'm left with, again, 3 minus 3, which is going to leave me with 4k squared over minus k all to the power of 3. And that would just become, well, 4k squared over minus k 3 to the power of 3, and those would be 4 over negative k. And if that's a positive constant, whatever number we put in here is going to be multiplied by a negative number, and this will give us a negative value, which means our graph looks like this, and it will have a positive point, or a maximum point. Okay, I was a little bit afraid when I saw this, and knowing we have to put it in there, but actually it worked out quite nicely in the end. And we can see now we didn't even have to have k to just figure out whether these points are minimum or maximum points.